and shape problems, extension and algebraic equations. This is the type of problem we'll often strike. It's age problems. Leanne's age 3 years ago, when doubled, is equal to triple her age 6 years ago. How old is Leanne now? So the question that they're asking, how old is Leanne now? That's what we want to find out. They haven't defined a variable for us, a pronumeral. So we're going to say, look, let it be something. Let her age now be X or Y or A, whatever you'd like it to be. And because the person reading our solution doesn't know what we chose, we say, let Leanne's age now equal X. So that's just defining that we're going to use this variable. Sorry, I don't have a good colour of pen. I'll switch. Now, her age 3 years ago, we've got to start building an equation here. 3 years ago, her age would be X minus 3. So her age of X minus 3, and that has to get doubled. So when we double her age 3 years ago, so I've got to double the whole lot, which means brackets and times by 2. That is equal to triple her age, so times 3, 6 years ago. So 6 years ago would be X minus 6. If it was 6 years in the future, it would be X plus 6. Now it may look like we've got two unknowns here because we're talking about her age 6 years ago and her age 3 years ago. Those aren't two unknown things because we can write them both in terms of X. And that's a really important thing when solving equations. If it looks like there's two different things we don't know, see if you can write them both in terms of something else. So we're not talking about her age 3 years ago and her age 6 years ago as two different things. We're talking about them both as X minus an amount. And that means we keep one type of pronumeral and we can solve our equation. So to solve this equation then, of course, when you've got brackets, you expand. 2 times X, 2 times negative 3, 3 times X, 3 times negative 6. So we have now equations with pronumerals on both sides. Subtract 2x from both sides. Negative 6 equals x minus 18. Add 18 to both sides. 12 equals x. And because they asked a question, how old is Leanne now? Then we say, therefore, Leanne is 12 years old now. So we make sure that we've answered their question. Another type of problem that we'll often get is a shape problem. So this one here, find x. There it is, it does not count. They've given you some information, and from this you'll have to find an equation that you can solve. So they've given you the perimeter. Sometimes in later questions they might give you the area. And so you've got to work out, well, what did they do to get the perimeter? They did 2 lots of this side and 2 lots of this side. So they would have done 2x plus 2x plus 3x plus 1 plus 3x plus 1 for the perimeter. And that would have got them 42. So you can see there's only one unknown, it's x. Now if you get an equation where the expression can be simplified, then do that first. Simplify this down. So my perimeter is, I've got 10x plus 2. That's an expression for the perimeter. And now I know that the perimeter is 42, so I substitute that in where the perimeter is. 42 equals 10x plus 2, and now I have an equation that I can solve. We're more used to having the unknown on the left-hand side. If you prefer, you can just swap them around. 10x plus 2, swap this side to that side, equals 42, and this is a nice friendly two-step equation. Deal with the plus 2 first, subtract 2 from both sides, 10x equals 40, divide by 10 on both sides, x equals 4. Now they didn't tell me this was centimetres, so I can't say that's centimetres. Sometimes they'd also say find the dimensions of the rectangle, and then I'd have to find x and then say, well, this is 2 times x, this is 8, and this one here is 13. So you might need to give more information depending on what the question asks for. But remember, work out what they did to get the answer. If they had area, they would have done this times this. Work out what was done, write an expression, turn it into an equation, and solve it.